All right, let's look at the free response questions on our test review. In this first question, the function g is defined and differentiable in the closed interval -7, 5 and satisfies that g of 0 equals 5. I'm going to go ahead and circle that. That's going to probably be some important information at some point. The graph of g prime, the derivative of g, consists of a semicircle and 3 line segments as shown in the figure above. So this is really important. Notice that our graph here is g prime, and I'm going to write that really big. This is g prime. So let's take a moment and annotate the different scenarios that we have here. G prime is the graph that we're looking at. So then g would, of course, be the integral of g prime, which means g would be the area of the graph that we're looking at. And then if I go in the other direction, g double prime would be the derivative of g prime, or the slope of the graph that we're looking at. Now if we take a moment to do that annotation, I think it's really going to help us for the rest of the problem. So let's look at part A. Question A says find g of 3 and g of -2. Now if I'm going to find g, if you look back at our annotation, we said that g is going to be equal to the area under the graph, and I want to know g of 3. What's strange about this question is that they haven't given us a starting place in the form of an integral. So often we have like an integral from 0 to x, and then we plug in 3 and we know that we're starting at 0. But here we don't have that. But what we do have is this information that they gave us at g of 0 we're equal to 5. And so what that means is that we're starting already at a value of 5, and then we're going to add to that whatever the area is from 0 to 3 of g prime of x dx. So 5 plus, so now I need to find the integral from 0 to 3. Well, from 0 to 2, right here I have a fourth of a circle whose radius is 2. So the area of that whole circle would be pi r squared, or pi 2 squared, which would be 4 pi. But this is only a fourth of it, so I'm going to divide that by 4. And we'll get pi for this area. And then I just need to go to 3. So I just need the area of this rectangle. Its base is 1 and the height is 3. So 1 times 3 is 3, divided by 2 would be 1.5. So 5 plus pi plus 1.5. And if you wanted to simplify that, you can, but we have done the calculus and you can stop right there. So g of -2. Same thing, we're going to start with 5, and we're going to add the integral from 0 to -2 of g prime of x dx. Now notice this time I'm starting at 0 and I'm going backwards to -2. And so whatever area that I get here, we're going to have to change it to negative. So I'm going to say negative because that area is going to be negative. And then we need to go back to the graph, and if I'm starting at 0 and going to -2, that is just the same quarter circle that we'd already found the area of. So this area is going to be pi also, but it is negative because we are going in the opposite direction. And so that's the answer to part A. So let's move on to part B. And since I'm on a new slide, let me take just a moment, and g prime is the graph. Integral of g prime is going to be area of the graph, and if I have to do g double prime, that's going to be slope. So that's our annotation. I just want it back there on the graph for the reference. Question B says, find the x-coordinate of each point of inflection of the graph of y equals g of x on the interval -7 to 5 and explain your reasoning. So point of inflection of g. Now this is a note card. Point of inflection means, it's of g, so let's not call it f. That means that the second derivative has to equal 0 and change signs. But am I looking at the second derivative? I'm not looking at the second derivative. I really need something in terms of the first derivative. And if you remember, a point of inflection means that g prime has a relative max or min. That's the information that we're going to use for this problem. So we're going to say, go back and look at the graph, and I have a relative maximum minimum. I have one right here when x is 0. I've got a minimum right here at x equals 2, and I've got another maximum up here at x equals 3. So here's how we're going to answer this question. We're going to say that G has inflection points. Sorry about that. G has inflection points at, and I'm going to break this up. I'm going to say at x equals 0 and x equals 3 because, and remember, whenever you write the word because, the very next thing that we should write is whatever is given to us. In this case, that's g prime. And the reason I know those are inflection points for g is because g prime changes from increasing to decreasing, and g has an inflection point at x equals 2 because g prime, I keep doing that, changes from, at 2 we change from decreasing to increasing. All right, final part. Part C, the function h. Okay, so now we have a new function h. Hold on, let me do this again. G prime is the graph. G is area, and G double prime would be slope. All right, h is equal to g minus 1/2 x squared. So I have a new function h, and it's g minus 1/2 x squared. Find the x-coordinate of each critical point of h and classify each critical point as the location of a relative minimum, relative maximum, or neither. Explain your reasoning. All right, so let's start off with critical point of h. Remember that critical point means that h prime is equal to 0 or undefined. So those are the numbers that we're looking for first of all. So I need to find h prime. If h is equal to g minus 1/2 x squared, then h prime is going to be g prime minus, and the derivative of 1/2 x squared would just be x. And I want to take this derivative and set it equal to 0. Now let's consider undefined. G prime is my graph, and is my graph ever undefined? No, because they told us originally that it is defined and differentiable on this interval that we're looking at. And then, of course, x is never going to be undefined because x is just a linear expression. So we don't have to consider undefined, but we are concerned with g prime minus x equal to 0. So what I'm really looking for here then is I want to know where the derivative of g might be equal to x. Or, in other words, where the graph that I'm looking at would be equal to x. So if we consider the graph, let's just start over here on the left side. In this region right here, all of my x coordinates they're like -7, -6, -5, -4, -3, but the graph here only goes down to -1. So there's no place in that region where the value of the graph is going to be equal to x. None of those places. Now the next part of the graph is this circle, and the equation for this circle, which is probably going to be helpful to us, would be the square root of 4 minus x squared. The way that I get there, x squared plus y squared is equal to r squared. The r is 2, so r squared would be 4. And then if I solve for y would be equal to the square root of 4 minus x squared. Plus or minus, obviously we're looking at the positive part. And my x coordinates for that section of the graph are from -2 to 2, and that graph goes from 0 up to 2, so I'm thinking that somewhere in there is probably a place where this graph would be equal to x. Another way to think about this would be to sketch the line y equals x, which would go about right there. And so that point right there is going to be where g prime is equal to x. So we need to figure out what that is. So for this section of the graph, I'm going to say that g prime, which is 4 minus x squared, equals x. And if I square both sides, then 4 minus x squared equals x squared. And I can add 4 is equal to 2x squared. X squared equals 2. If I divide by 2, and then x is going to be equal to plus or minus the square root of 2. Now it can't be negative for our situation because the circle graph is all positive. So I'm just interested in the positive aspect of this. So that is one of my critical numbers. X is equal to the positive square root of 2. So that's one of them. Now if you notice on the graph, they actually gave us the other one, which was nice. This point right here, the point 3, 3, I have an x coordinate of 3, and I have a function value, a g prime value of 3, and so those are equal. And especially if you consider the line y equals x, those are our only two possible critical values. So my critical numbers are x equals square root of 2 and 3. So now they want us to identify whether they are a relative minimum, a relative maximum, or neither. So I'm going to erase my algebra here. And so usually the way that we do that is with a number line. Square root of 2 and 3. Now remember, I'm looking for if these are minimums or maximums on h. And my h derivative is g prime minus x. So let's pick a number over here less than square root of 2. I'm going to choose 0. 0 is in this interval. And if I substitute 0 into my derivative, h prime of 0, well, that's going to be g prime of 0 minus 0. G prime of 0 is positive 2, in fact, minus 0, and so this is equal to 2. And it doesn't matter that it equals 2. What matters is that this is positive. Now let's pick a number between the square root of 2 and 3, such as 2. If I do h prime of 2, that's going to be g prime of 2 minus 2. And g prime of 2, if I look at my graph, g prime of 2 is 0. Minus 2 would, of course, be negative 2. It doesn't matter that it's 2. What matters is that it's negative. And finally, if I pick a number bigger than 3, such as 4, h prime of 4 would be g prime of 4 minus 4. And g prime of 4 is, let's see, something smaller than 4. This is going to come out negative, I believe. So negative is less than 0. It doesn't matter what the value is, it's going to come out negative because the graph at 4 is something smaller than 3. All right, so we have our sign chart there. It shows us that since we're changing from positive to negative at square root of 2, that would be a maximum. And since we change, well, I'm sorry, at 3, there's no sign change. It's negative on both sides of 3. So 3 would be neither. So I've done a lot of writing here. I'm going to erase my sign chart. And then let's write our answer. So we're going to say, we've listed our critical numbers. And we're going to say H has a relative max at x equals square root of 2 because h prime, well, actually, I'm sorry, we should follow because with what we're given. In this case, we're given g prime, but that wasn't really what we were dealing with here. Remember, we were dealing with g prime minus x. So I'm going to say g prime minus x, which equals h prime. Changes from positive to negative. And h has neither a min or max at x equals 3 because h prime equal to g prime minus x does not change signs. Definitely a challenging problem there. Remember, sometimes I like to put the more challenging problems on the review. But that's how you would work part C. Let's move on to the last question. And remember on this question, I'm going to let you use a calculator. It was a calculator question when it appeared on the test. We have this region R in the first quadrant bounded by the graph y equals 4 natural log of 3 minus x. The horizontal line x, y equals 6, and the vertical line x equals 2, as shown in the figure above or to the left here on my screen. Find the area of R. So, area of R, I want you to write down our formula, integral from a to b, top minus bottom. So for this graph, we're going to integrate from a to b. Now our a and b, they're going to be x numbers. And so in this case, 0 to 2. The top here would be 6 minus the bottom, and that's 4 natural log of 3 minus x dx. And then you do have a calculator. You can just enter that into your calculator, and if you do, you should get the answer 6.816 with 3 decimal places. Let's move on to part B. Question B, we've got the same region. We want to find the volume of the solid generated when R is revolved about the horizontal line y equals 8. So I'm going to add that horizontal line y equals 8 to my diagram over here. That's going to be a line somewhere up here. Sorry, it won't let me. Let me see if I can put that a little higher. Y equals 8. So somewhere up here, we're going to rotate around this line. And so that means I'm definitely going to have a hole. So we're doing the washer method. I have a horizontal axis that I'm rotating around, and so this is going to be a dx volume, A to B. I'm going to write my equation since it's a washer, pi times big R squared minus little r squared dx. These are x values are A and B since the dx integral, so 0 to 2 of pi big R squared minus little r squared. Now what I would want you to do is to draw these two radiuses, radii, the big R and the little r, from the axis all the way to the edge of the graph. That's the big R. And then from the axis to the edge of the hole, that's going to be the little r. And then if we want to know how long those radii are, top minus bottom. So my big R, the top is 8 minus the bottom, that would be that 4 natural log of 3 minus x function. So that's my big R, and I need to square it, minus the little r, which is going to be top minus bottom. In this case would just be 8 minus 6. Or you could just put 2. Either one would be fine. Squared, of course, and dx at the end. Even though this is a calculator question, you must show this integral. 2 points of the rubric are just for this integral. And you can type it into your calculator, and if you do, you should get the answer 168.179. All right, let's move on to Part C. In Part C, same region. This time, each cross-section perpendicular to the x-axis is a square. So we're doing cross-sections that are squares. One side of that square is going to be right there. We're still going perpendicular to the x-axis. It's still a horizontal axis. So we're going to do integral from A to B. Our formula is area of the base dx. In this case, since our cross sections are squares, it's going to be side squared dx. So I'm going to integrate. My A and B are still 0 and 2. The length of one side of the square is going to be top minus bottom, which in this case is 6 minus 4 natural log of 3 minus x. That is the length of a side. I need to square it, dx. And then you can type that into your calculator. And if you do, you should get a volume of 26.266.